Hello everyone, myself Fathimathul of 3rd MSc Computer Science. Here I'm going to take a presentation on topic image segmentation. Image segmentation is actually a very interesting topic which comes under the fundamental steps in image processing. So yeah, let's begin. These are the topics that we have been discussed. That is, let's introduction or fundamental steps in image processing and the fundamentals of image segmentations and point detections and line detections. We will be discussing all of this one by one in our presentation. For the better understanding of the concept of image segmentation, let's recall of what are the fundamental steps in the image processing. As you all are very familiar with this picture or this figure that we have already studied, this is the fundamental steps in image processing, and this contains a 10 processing system or 10 processes, that is image acquisition, image enhancement, image restoration, color image processing, wavelet and multi-resolution processing, compression, morphological processing, segmentation, representation and descriptions, object recognitions. So if you are looking about from here, first process to this process, that is morphological process, in all about this process we are inputting image, and the output that we have received from this processor are also images. That is, our output of these steps are generally images. Both input and output are generally images. But from here to this, that is from morphological processing to object recognition, these 4 steps actually input an image, but it's produce an output as an attributes of image that is actually extracting from that images. So that is the thing that we have to be note from this concept. That is, you can see here 8th process, that is segmentation, is our topic. So we can see the segmentation, which is a fundamental step or process in digital image processing. And in segmentation we are inputting an image, but the output is some attributes which are extracting from that image. Yeah. Next, we are going to discuss about fundamentals of image segmentation. As we already discussed that this image segmentation which comes under the fundamentals of image processing. So next we are going to discussing about what is actually image segmentation. Yes, the image segmentation, as its name suggests, that it is the segmentation of one image into different subgroups or subregions. That is partitioning or segregating an image into a different subgroups or region. That is actually the image segmentation. And one thing we have to focus or not while doing image segmentation is the level to which the subdivision is carried. That depends on the problem being solved. That is, the segmentation process have to be stopped when the objects of interest in an application have been isolated. This is a thing that we have to mind when we are segmenting an image. Let's discuss about the definition of image segmentation by using some mathematical or some graphical images. Here you can see that here we have an image, that is, that image can be called as an R, and that image can be partitioned into many regions or many subgroups, can be called named as R1, R2, R3, etc. Rn. So the whole image, it is called R, and its subdivisions or objects are called R1, R2, etc. And here we have one region, R1 is one region, R3 is another region, R4 is another region, R2 is another region, and that region itself contains sub regions. So we are regioning, or we are segmenting, or we are partitioning an image based on mainly some types of criteria that we will be discussed in our later slides. Here you just understand the concept that we are the R is called an image, and we are segmenting that image R into different subgroups or sub object, which is called R1, R2, R2, etc. Ri. Yeah, here there is an example. Here you can see a matrix, that is 5 by 5 matrix, and that contain lots of values, and we can segment or partitioning those image based on some similarity or based on some changes in that images. Let's look at here. These region contains the same values, so based on that similarity we can partition that region as an R1, that can be considered as an first partition. And let's look here. Look this, these contain the similar values, so we can partition those region based on that similarity. So we have selected second partition R2. Next, another thing, these all values are similar, so based on that similarity or based on that changes, we can consider these as another partition or another region. So from this entire image we are partitioning that image into R1, R2 and R3 based on some similarity or based on some discontinuity. So here that same image I am just highlighting with some color so that you can easily understand the region based on that colors. This is one region, this is another, and this is another. So this is basically this is just partitioning an image into different region. For example, for better understanding, suppose if you have an image that contain a flower, car, TV, etc. etc. So various objects are available in that particular image. So if you want to segment or if you want to segregate each of those sub objects in an image, we can use the segmentation method. So basically a segmentation is the process of partitioning a digital image into multiple regions and extracting a meaningful information from that. Actually this process is also called a region of interest or ROI. Okay. So we discussed about the definition of image segmentation. And there are some characteristics of segmentation process. Let R represent the entire image region, and RAs are subgroups of that or sub-images of that image. So we have 5 characteristics, that is UI equal to 1 raised to n, Ri equal to R. That is, let R is an entire or an original image and Ri is subdivided images. That is, when you are taking a union or when you are sum up those of the subdivided images, you can form that original image. That is one characteristic. Then second one is Ri should be connected region. That is, the sub-region are not to be opponent. It should be connected. Next, Ri intersection R1 is equal to 5. That is, when we are intersecting or when we are trying to intersect or when we are trying to connect the different region, you will not get or you are not able to find the similarities in between different region, because we are regioning or we are partitioning those images into different groups based on some similarity or based on some changes. That is, the partitioned images have less similarity. The partitioned images have less similarity or they have no connection. So when you are intersecting the different subdivided images, you will not find or you will not able to find the similarities in between them or coherence between them. And next one is P of Ri is equal to true for I is equal to 1 to 3. Here the P of Ri is indicating the predicate, and that indicates some properties over the region. And last one is P of Ri union Rj is equal to false. Here Ri is a subdivided image of of one image, and Rj is a subdivided or sub image of another image. Or when you are unioning or when you are sum up the subdivided image of one image and another image, you will get the false result. So these are some of the characteristics of segmentation process that you have to mind out. And as I told earlier, the image segmentations are based on mainly one of two basic properties of intensity value. That is, based on the properties of an intensity value, the segmentation can be done. That is, that two properties are similarity principle or discontinuity principle. First one is similarity and second one is discontinuity principle. The similarity principle itself is called a region approach, and the discontinuity principle itself is called a boundary approach. And what is actually similarity principle? In similarity principle, if the objective is to group pixels based on common property to extract a coherent region, that is, we are segmenting an image or we are partitioning an image based on some similarities between the values in that image or between the objects in that image. If you have some same property between some images, you are partitioning that images into a single group. So based on similarity we can segment. And another property is discontinuity principle. The objective is to extract region that differ in properties like intensity, color, texture, etc. That is, in discontinuity principle, which is actually an opposite approach of a similarity principle. That is, we are segmenting an image based on some dissimilarity or based on some changes or based on some what is called dissimilarities between them. That is, if two sub-objects in that image have no similarities in between them, such objects can be partitioned into different groups. That is, this can be intensity, color, texture. If the color or texture or intensity of the images, sub-images in the original image contains or different, then you can partition those images into different groups. So we are basically maintaining or segmenting or partitioning an algorithm or an image based on similarity principle or discontinuity principle. And we have different methods for finding the discontinuity approach or a similarity. And under discontinuity we can find the discontinuity on our image segmentation by using isolated point, line detection, edge detection. And we can also find the similarity by using the methods called thresholding, region growing, region split, region merge, etc. So here we are mainly discussing about the method for finding discontinuities. That is, mainly we are discussing about isolated point and line detection. So our next section is point detection, which is one of the method for finding discontinuity. Actually, the detection of isolated point is one method, comes under discontinuity or finding discontinuity, and it is actually done using sharpening filter. And we use mainly second order derivative using Laplacian for detecting isolated points. And the processor comes, or the first process is, a point has been detected at a particular location, we can call it as xy, and on which the kernel is centered. If the absolute value of that response of that filter at that point exceeds a specified threshold, such points are labeled 1 and all other labeled as 0 in the output image, thus producing a binary image. That is, basically if for isolating or for detecting a point, we have given some function. We have given some function, and also we have given a threshold value, and the values in that the matrix, 3 by 3 matrix or some other matrix or values we have in our image should, if it is exceed the threshold, the given threshold value, then we are labeled it as 1, otherwise we are labeled it as 0. So this leads us to get a binary result. So the t is here referred as a threshold, and based on that function, the value we get from that image is greater than threshold value, we will point it as 1, and other it will be 0. So here we can see that at last we are detecting 1. We're using that function, particular that value got 1 means that value at that position is greater than threshold. That's why that we marked as 1. So this is how we are detecting a point in an image segmentation. Next we are going to discussing about line detection, which is also another method for finding discontinuity in a line segmentation. Here we also use the second order derivative. In point detection also we are using second order derivative, and here also we are using second order derivations, and which result a stronger filter response and produce a thinner line than first determination, which means for the thicker line we use first order derivative, and for thinner line, for stronger filter, we use second order derivatives. And kernel here for horizontal line for detection is if it is any line at given angle plus 45 degree. That is, we have line detection can be done in horizontal, vertical or plus 5. That is a given line plus 45 degree or a given line minus 45 degree. In this situation we can detect line detection. That is, if it's any line is given at a given angle plus 45 degree, that is a given angle which is horizontal plus 45 degree, we are mark it as this form. That is, if a line detection we have given an horizontal, we are mark it as this form, and if it is in the vertical form, we are mark it as, we are detecting a line detection as like this. And if is a given line plus 45 degree, we are mark it as, or we are detecting a line has like this, and a particular given line minus 45 degree, we are mark it as, we are detecting a line as like this. And here the horizontal mask will result the max response when a line passes through the middle row of the mask with a constant background. And yeah, so this is how we are detecting a line in a line segmentation process, and this is just an example of a line detection process using second order derivative. Yeah, that's all about our presentation. So let's conclude. At first we have discussed about the fundamental steps in digital processing, and as we know that the image segmentation, which comes under one of the process under the fundamental steps in image processing. And actually the image segmentation is one that segmenting or partitioning an image into different region, and basically we are segmenting this image based on some properties of image intensity value, that is discontinuity and similarity. That is, if we have an image, if there is some similarities in between the objects inside an image, we are partitioning based on that similarity. Such types of approach is called similarity approach, and we are partitioning or segmenting or segregating an image based on some changes occurs in there. We use a discontinuity operation. And for finding discontinuity method, or for finding discontinuity, we have some methods, that is line detection, point detection and edge detection. Mainly in this topic I have discussed about point detection and line detection. The edge detection will be discussed by my other colleague in other presentation. So we discuss about line detection and point detections. So these all are the basic or a brief note or a presentation on topic image segmentation. I hope you guys understood this concept, and this is the textbook reference that I have used for this presentation. You can also refer for a better understanding of this concept. So that's all. Thank you. Have a nice day.